Morning, everyone. I did my hackathon for monitoring light intensity. So the purpose of the project was to design an app that could visualize data coming from a Tesla 2 so that hopefully once it's in production, you could put it next to your houseplant, track the light intensity over the course of a day, over a week, over a month, and determine how much light it's getting that you may or may not know how much it's getting throughout the day when you're not there. So for me personally, I have a peace lily and it's sitting in my room. I have no idea what kind of light is in there. And it's kind of wilting and the tips are browning. So hopefully something like this would help out in that situation. So the way I did this was I leveraged a couple different things. First, I used the Tesla to actually pull the data. And then I actually have a very rudimentary HTTP server running on the Tesla itself. And what's happening is the server that's running my website is pulling at regular intervals. But then at first I tried to just render that data immediately, but what I found was it would stutter. So eventually what you can see on the left is I added a buffer. So basically there is a set interval that's collecting the data from the Tesla, and then there's another set interval at the same interval that's emitting that data through a WebSocket. So with my website, as you can probably imagine, it is with React, and what's happening is once it receives data from the socket or the socket channel, it's going to update the state, and it's going to render a rectangle onto the DOM. And so the way that I did that is I'm leveraging a couple different libraries. I'm using D3 to help me with some of the calculations, but then the graphic itself is an SVG, or a scalable vector graphic tag from HTML5. So what's happening is I'm leveraging some D3 code, and I'll show you right here. And it's really interesting. What I found out with D3 is that there's a lot of overlap with what React and D3 tried to do. There's a whole section of D3 that just centers around DOM manipulation, DOM selection, almost like jQuery. And if you're using React, there was a challenge of trying to figure out when I should use what. But eventually what I landed on was using React mostly to render the DOMs and the elements, and then just using the D3 libraries to generate the mathematical computations of how big or how wide the rectangle should be. So what's happening here is, let me go up to the top. On a component did mount, I start a listener for my socket right here. And as you can see, when it grabs a piece of data, it's slicing off the current data set. It's basically dropping off the most, the oldest column, taking that off, and then tacking on a new column to the state array. And then it draws an axis on first mount, and then it doesn't do anything after that. So then what it's actually returning with the render function is an SVG tag plus a bunch of rectangles, which are mapped through based on state. So one of the interesting things is at first when I was doing this, it was rendering every rectangle all the time. And so what I learned was you have to make sure your key is unique. And if you can React can refer back to the key, it can know that it doesn't have to re-render that. So now it's actually properly just tacking on a new rectangle at every interval versus rendering every rectangle all the time. So that's my app. Moving forward, phase 2, I'd like to flesh out some of the axes, maybe use an actual light meter to determine the intensity. And actually, let me just prove that it actually works. Come on, flashlight. There we go. So yeah. So given this, next steps, I'd like to compute some aggregate data, push that to an historical database, and then hopefully start to compute daily and weekly rollups for what the light intensity is. That's my project. Thank you. Come on.